Okay, let's take a look at number 34, an application problem. We're going to let X be the number of batches of cakes. Y be the number of batches of cookies. Okay, let's read the problem. A bakery makes both cakes and cookies. Each batch of cakes requires 2 hours in the oven and 3 hours in the decorating room. Each batch of cookies needs 1.5 hours in the oven and 2/3 of an hour in the decorating room. The oven is available no more than 15 hours a day, while the decorating room can be used no more than 13 hours a day. How many batches of cakes and cookies should the bakery make in order to maximize profits if cookies produce a profit of $20 per batch and cakes produce a profit of $30 per batch? So they want to maximize 30x plus 20y. That's going to be the formula for their profit. Okay, so that's our objective function that we want to maximize. Now, we need an inequality for the oven and an inequality for the decorating room. Okay, for the oven, it takes 2 hours for a cake, 2x, and 1.5 hours for a cookie. That seems like an awfully long time. And, it's got to be less than or equal to, got my inequality going the wrong way, less than or equal to 15 hours a day. And for the cookies, or for the decorating room, it takes 3 hours for the cake, plus 2/3 of an hour for each batch of cookies, and that we want less than or equal to 13. And we're going to count by 2's. We know we want x and y to both be greater than 0. There's no way they could be negative. Greater than or equal to 0. Okay. So I want to take my first equation to get up my first line, and if x is 0, then y is 10. If y is 0, then x is 7.5. So here's 7 is right in between, and in between there would be 7.5. Okay, my lines are going to be crooked, but that's the best I can do on this computer screen. 3x plus 2/3 y equal to 13. Okay, if x is 0, 2/3 y equals 13, y equals 39/2, which is 19.5. 19.5 is going to be way up there. Okay, and then when y is 0, 13/3, which would be 4 1/3. Okay, here's 5 approximately, so 4 1/3 would be about here. Okay, now as we look at 0, 0, it yields a true statement for both of these. So we're shading both of these down, So the intersection, I'm trying to get the green, intersection, I want to stay in the first quadrant if I can. Okay, is that little region there. Now this point is 0, 10. This point is 4 1/3, not a half, 4 1/3, or 13/3. 0. And this point here is a little difficult to see, but that should be about 3/6, and my lines are off a bit, but that's where it should be if I could put my graph paper down and use a ruler and drawing it flat, but my pen slips when it's on this computer screen. Okay, so those are the points we want to test in our profit objective function. So 30, we'll do 0, 10 first. 30 times 0 plus 20 times 10. That gives us $200. 3, 6. 30 times 3 plus 20 times 6 is 90 plus 120. So that's going to be $210. And then 0, 13/3 is going to give us, no, it's 13/3 0. Let me get that switched. Okay, 13/3, comma 0 is going to give us 30 times 13/3 plus 0 would be, I believe, 130. So it looks like the winner is 3, 6. So 3 batches of cakes, and 6 batches of cookies.